Hi everyone, I'm Anish, the founder of DevVoid, and today we'll be continuing with the next episode of DSX AI. Today, first of all, let's see till where we have come up in our problems, right? So here we go, right? So we have solved it by search, stack, and all of those things. In the previous ones, we have solved regarding linked lists, and the ones we solved in the last episode was merge two sorted lists. This episode, we will look into linked list cycle, and that will be the problem statement. Well, let's just go right into it, right? Oh, wait, just one sec. I want to just go back before we showcase this. I have started another thing called socials.devoid, which I just want to just quickly showcase. So if you see here, socials.devoid is a free way for everyone to make the digital identity. It's free simply because I just want to see its value and whether it actually makes sense to everyone, right? Otherwise, there's no point in doing anything more to it, right? So the point here is go ahead and give it a try. You can get a free business card or free card for you guys to showcase yourself online, right? That's the whole point of this. So go ahead and make a link and try it out. That's all I'm going to say. This also reminds me of one more thing that DevVoid has been working on. That is developers.devoid. This is a network. Okay. It's a free network for people to apply and join, right? What's the point of this? So any kind of projects we get, we might outsource here, or we might have some discussions and do some products together. It's basically, I will interview all of you guys, whoever applies for this. And if you're good to go, then we can discuss about either partnering up and doing some projects together, or working on some contracts from DevVoid and earning some, cash in the side and stuff like that, right? So that's the whole point of this network that I'm building as well. So check it out, devs.devoid and socials.devoid.org. But coming back, let's look at the problem, okay? So the problem here is linked list cycle. Okay. So from now on, how I'm going to do things is I want to move things a bit faster, but at the same time, I want to have more consistency in these videos and stuff. So, there's more value I can give, right? So the point is I'm going to kind of solve the problems prior to this, practice a bit and solve it. And then I'll show the submission section, right? From here onwards, I'll be very clear. The AI aspects will be your task from now on. The whole point of this course is you guys should use AI. Where at any point, if you guys need me to teach that, I'll teach you. But we already have previous episodes where we have that, right? I will do a little bit of it at the end, but that's how it's going to be for most of the time. So stay tuned for the end if you want to see how to use AI for this problem. But without further ado, let's just begin with the problem, look into it and solve it, right? That's how it's going to be. So let's see the problem. Linked list cycle. Given the head of a linked list. Determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS, again, these are internal factors. That's not how it's actually represented. But the reason they mention that is because if you see in the head, input, it's called head and then pause. Got it? But think of it visually for now. Do not think of it in this manner. Okay? Because if you see in the right side here, right, to be honest, it's a very not so nice defined ones, but anyways, prompt, not so nice defined input out statement, but you can understand it from that. I'll tell you how. Look at this here. They have defined on the right side what is the structure of a linked list. We already solved linked list enough. Look at the previous videos if you haven't if you come to this video directly, please. And yeah, so we have solved this prompt enough to understand that this is how to access linked list and whatnot. So that should be good, right? And overall, let's visualize. Okay, what is a cycle? What is a linked list? In this case, how do you use linked list to find cycles? And say yes or no. That's it. There's going to be a nice algorithm we'll learn. There are 3 solutions as far as time complexity is concerned, but there is a lot more if you think about it from a different perspective. But I will be talking into 2 only, and those are like the more optimal solutions. The brute force one, I'm going to completely ignore for this one. So if you guys want to explore that, sure, I would say definitely use AI for that, right? This is the point here. But I'm going to talk about the more optimized solutions right now, and let's just quickly dive into the whiteboard, shall we? So look at the first problem statement, that is 3204, 320 and minus 4. Okay. And this is how it's going to be, right? Just one sec. I was not using this. I don't know why I was not using that. So 320 and let's reduce this. So 320 minus 4. Let's come back to this. Okay. So firstly, what's happening here? You're going front, 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 and then coming back. So when you come back, notice something here. Do you see this thing that's happening here? 1, 2, 3. 1, 2, 3. 1, 2, 3. So you see, it forms something like a circle, right? Or in this case, it's also called as a cycle because it keeps repeating indefinitely, right? So, I'm pretty sure most of you guys might know what is water cycle and things like that, right? So, this represents something like that. Some kind of structure like that happens, right? A circular pattern which repeats itself over and over. That is what a cycle is, right? It can be anything. There's a lot of possibilities just to make you understand what cycles are. So 3, 2, 0, and -4. It can even be a self loop like this. Got it? That's a cycle. It can be from here to here to here, like we already saw just now. It can even be from till here, starting like this. It can even be something like, from here like this. This is a cycle, one cycle like this. So point is, any kind of way to go back, right? In this case, forming a closed kind of a structure which keeps going through indefinitely is a cycle. Okay, in this case, right? So, well, how do you find that out, right? Well, interestingly enough, I told a very peculiar word over here. I told indefinitely, right? So if you think about it over here, right? 3, 2, 0, -4 in the problem that they have given. If I keep going front and next and next and next and next and next, what's going to happen? Think about that. I go next. Well, I go here. I go next, I go here, I go here. Then I come back and I go here and I go here. Come back. It never stops if I keep going next because there is no stop factor. There's no place that says my next is going to be null, and that was our criteria, if you remember in the previous problems, to stop iterating a linked list. That is, the next does not exist. But in this case, there is no such point. So our loop will become infinite and it will never end. Got it? If you say while next is equal to null, while next is not equal to null and loop it, it's never going to end. And that's what I want to bring into picture here. That is the issues with cycles, and that's why you should not make cycles, first of all, in a lot of scenarios, because it could cause infinite loops. Got it? Now, coming back to the problem, let's see how to approach this. Okay. I do remember us solving hash maps, and that's a topic that has been covered. So I'll use that for one of my solutions. Okay. So think about this. Imagine there is a structure, a data structure that stores the address. Now, very important. Even though the values are unique here, why can't we use the values? Because I do not remember them mentioning in the problem at any point saying the values are unique. Okay. If they were, sure, we can use it. But a more general solution is using the address, right? Because if you're coming back to the same location, we're coming back to the same address. Got it? So how do you do that? How do you leverage that? Right? Well, interestingly enough, we can just do it in this manner. Okay? We can just say that over here, if let's think of the pseudocode for this, okay? Or let's think of the logic first, actually, that's my bad. 3, 2, 0, -4. Okay? Think of it like this. Okay? What will I do? I will go to 3. I'll store the address of 3. Call it as ADDR1. Okay? In some value. Okay? I'll just call it as address 1. That's it. Next one, I'll go to 2 because that's next in my iteration. I'll store address 2. So ADDR2. I'll go next. I'll store ADDR3. I'll go next. ADDR4. I'll come back and boom. I go back and I see that I have ADDR2, which is already present. Hence, it's a cycle. That's it. The logic is as simple as that. Store the address every time. Use something that allows you to do quick lookup, that is quick search of whether an address exists or not, and then leverage that to find the solution. That's pretty much it. What do we do for that? Let's see the code quickly, shall we? See the code. It's going to be, I have already submitted it. That's how we're going to do from now, I told you, right? So it's right here. This is submission. I hope everyone can see this properly, hopefully. But what are we doing here? This is the problem statement, right? That they already given define hash cycle. So that's the function that they're given and the function definition. I will, for your understanding, copy it over here so that we can run it up and experiment with it a bit, right? So what's happening here? Hash map is being created, which is the data structure used for quick lookup. Okay, quick lookup, instant searches, very important. Now, how do we utilize that? Okay, so how do we utilize that is we go here. It's not really quick lookup only. It's also for showing unique items and stuff. But anyways, I might have told the wrong wording there, but that's fine. Point here is for this one, it's very nice, is because we can use it to check a lot of things, right? One is we check at any point. What do we check? Whether the address exists in this storage or not. If the address exists, that is, if temp, which is the address, is present in this hash map, that is our storage of addresses, return true. That means what? If address already present, then we're going back to something that we already visited. If that's the case, that's a cycle. Therefore, return true. Finally, every loop, if there's no such address conflicts, then we'll add that address to our storage as a visited address and then go next. And then go next. And go on until we reach the end, if there is an end, or until we reach a repetition, if there is a repetition. One or the other is possible for sure. And that is the solution for this, pretty much. So we'll deep dive this a bit more, but I already solved the solution and I already submitted it. It's going to be good to go. Second solution though, but before going to second solution, very importantly, what do you need to see? The time complexity and the space complexity. Okay. In this case, theoretically, it's possible that the cycle could be found out instantly. How? Because let's say the beginning element only is self loop like this, right? We're done, instant. Even though there's n number of items after this, it doesn't matter. But what's the worst case? Worst case is going one by one till the end, right? And then finding that the last one has some loop, goes back to any point. In this case, we need to traverse the entire linked list, which takes us O of n time, because we go one by one for n items. That's it. So O of n time, and the time complexity is going to be O of n. Of course, mathematically, I can prove you why this is the case by taking some examples and doing it. But at this point, I'm assuming you guys have understood. If not, go back to the initial parts where I explain everything mathematically and stuff like that, right? Also, by the way, at any point, if you guys want me to go more deeper, I will go into it. I'm trying to make a little bit more shorter videos and more chunkier ones so that you guys can digest it and not have a big watch time, right? That's what I'm trying to focus on right now. But if you like my previous form where I go a lot in depth, you can tell me that, and that's also good to go. Finally, space complexity. We store every address, right? So if there's n items, there's n addresses. If there's n-1 items, there's n-1 addresses. That is why, just like that, we have O of n space complexity as well. Okay. This is the one solution. That's a very good solution. But there's another solution that is also quite interesting. This one, I forgot the exact word for it, but it's something like Floyd's algorithm, something like that. But the point of this is like this. Take two different pointers, okay? Let's do it like this. Take two different pointers. What is the pointer? It points to a memory address, right? It's a variable that stores a memory address. So it goes towards that. So we'll take P1 and P2. Let them both travel at different speeds. What is traveling? Okay. Moving. Next. Let's say P1 goes at speed 1 and P2 goes at speed 2. Okay. That is one step at a time, and P2 goes at 2 steps at a time. So let's start at the beginning, same points. P1 and P2 is right here. Okay. What happens to, I'll put 1, 2 like this. What happens to 1 in the next step? It's going to go at speed 1. So 1 will be here. But 2 will be where? 2 will be over here. Okay? You understood that, right? What happens after that? We'll take just this part because it's going to be in this part only after this. 1 is going to go here and 2 is going to go 2 steps. So 1, 2. 2 will come back here. Okay? This is second step. What's the third step now? Here, here, here. Okay? And boom. So 1 will go 1 step and 2 will go 1, 2. So 2 is also right in the same spot. Okay? So why did I show this? Is because if 2 pointers go at differing speeds, they will meet at one point if it is a cycle. Because imagine this, it's not a cycle. The one that's moving at double speed will never come back. It will reach the end and done. Right? So because it came back and met, that's why it's a cycle. Simple as that. That is another logic. Take 2 pointers, move them at different speeds, and if they meet, it's a cycle. If they reach the end, it's not a cycle. Simple as that. And that is the other logic, which is, if I go to all submissions and see the latest one, I did some typos in between, so that's why runtime errors over there and not. But yeah. So if you see here, I think it should be solution right here. Cool. So what's happening here? If not head or not head dot next, return false. Why is this important? Because according to the problem statement, we could have empty linked list. Okay. So initially, if it's empty linked list or the next item is, how to say, or the next item is empty, then there's nothing to check because there's only one item or there's 0 items if this condition is true. One item self loop, well, it's possible, but in this case, that's not how it works. So that's why it's good. Okay. And head, yeah. So you got what I'm saying, right? Now, next point is slow is equal to head and fast is equal to head dot next. Okay. So what we're doing? We took 2 pointers starting at different locations right now. We can start at the same point as well, but we're starting at different locations right now. Okay. So the reason we didn't start is because in my logic, I do slow is equal to fast, right? So if you start at the same point, then there also some issues will be there. But anyways, the point is I'm starting pointer 1, slower pointer at the first location and the faster pointer at the next location. Okay. Okay. Now, while fast and fast dot next, okay, while fast and fast dot next. Actually, I told about a self point, right? It's actually covered as well. Sorry, I did a small mistake there while telling in the previous one. But the point, anyways, but while fast and fast dot next, right? What does that say? It says that if my next 2 steps exist, why is that important? Tell me. It's because if you see, right, if I go 2 steps front and there's nothing there, it's empty 1 step before only. How can I even go 2 steps front? Right. That's why I want to know my current step as well as the next step is not empty. Because if I don't know that, I cannot go after that, right? I cannot go 2 steps forward if there's no 2 steps only. Understood? That's why I'm checking this condition over here. So if I want to go 2 steps forward, I want to know I have 2 steps available to me. Otherwise, there's only 1 step, right? How can I go 2 steps forward? Right? It's simple as that. That's why we're checking while fast and fast dot next. Because if you check for the fast one, which is the one that's in the front always, the back one check is not needed for slow. Got it? So as long as we have fast checking, we don't have to worry about slow. Then what do we do? Is if slow is equal to fast, that is, they are the same thing. We saw, right? 1 and 2 having the same address. That's why this is happening. If slow is equal to fast, return true. That's it. Otherwise, take 1 step forward for slow and 2 steps forward for fast. And keep repeating until either you reach the end, that is while fast and fast dot next, one of them will be null. Return false. if it's not, it reaches the end, because if it is the end, there's no cycle. If there's no cycle, the function says give me false. That's why we're doing that. Cool. And that is the overall summary of things. But very importantly, we did not finish the analysis part of this. What do you guys think would be the time complexity? Right. I'm just going to give it like maybe a couple of seconds. If you guys have reached this point, it'll be nice, to know that there are people looking at this point. So just comment down your ideas on what's the time complexity for this one, time and space, right? I will tell the solution in like a couple of seconds, right? In 3, 2, 1, go. So pause right here if you want to submit. Otherwise, I'm just telling the solution right now. And the solution is as follows. Okay. Right now, if you see here, we have two-pointer approach. Okay. What happens? Always two pointers for storing memory addresses. Always. Irrespective of the size of the linked list. Right. So space is constant. Hence O of 1 complexity. Done. Time-wise, we are still iterating through the linked list one by one. Okay. But depending on the speeds 1 and 2, right? We're going to do some maths for it, but I'm not going to do that right now. But the speed could be, how to say, think about it like this, right? Think about it like this. I just give you an example. I think that's a better way to understand. In the previous one, as soon as I reach the end, the worst case would be like when I come back, right? Done. So always going to be like n plus 1, but n is a bigger factor, so n. In this case, it's not as simple as that, but there is a nice n factor coming out. That is, you see here, what happens? I'm here, 1, and I'm here, 2. Next step, what happens? 1 is here, and 2 is here. Next step. So again, step 2, step 2. Next step, what happens? 1 is here, and 2 is 1, 2. In this case, it gets caught quite fast. But depending on cases, which I want you guys to try out, it could get caught in a little bit more slower pattern. But don't worry about it. The complexity comes out similar to O of n only because of how it's set up and done. So time complexity is O of n because think of it just as iterating through the linked list and then you're done. Okay. And that is time complexity, O of n. Space complexity is O of 1. Okay. Space O of 1, time O of n, and that makes this a better solution compared to the previous one because previous one had space O of n. This is the most optimal possible ones, that is O of n time and O of 1 space for this problem. So if there is one solution that you guys want to catch hold of for this problem statement, it would be this. But always I entertain that you guys should always learn more combinations of possibilities and whatnot because it's nice and it gives you more ideas to try for the other problems. Okay. So explore a bit, right? Let's just quickly do our AI sessions for this. So I'll just go here code and copy this one right here, paste it here. Sorry, not the code. Why did I paste the code? Sorry, right here. And what do you want to ask? Yeah, I mean, different solutions. Want this. After you guys are able to solve it in one way or couple of ways, only then you should ask this, okay? Very important. If you're going to try this directly, then that's stupidity and it's going to not help you learn. So don't never directly ask for a solution like this, especially when you're learning, okay? So you see, there's like hash set, there's 2 pointers, which is Floyd cycle detection, and it's also called as Tortoise and Hare because one moves slowly, other moves fast, right? And there is marking nodes. And there's a lot of other solutions. You can see. Look at this. There's just 5 different solutions that ChatGPT is directly telling you. If you ask it a bit more questions, it's going to tell you more solutions. Got it? So why I'm telling this is because explore it a bit more, guys. Okay? Otherwise, there's no point. So I have given you 2 solutions. There's a lot more to it. There's multiple different approaches of doing anything. The more you know, the more weapons you have in your arsenal. Right? The more weapons you have, the better utilization you can do based on scenarios. Got it? That's all I'm going to say. That's pretty much it from my side. I have a little bit of a throat pain, so that's why it was not like I was pausing a bit more and stuff, whatnot. But yeah, it will be better going forward. I am trying to be more consistent in this programs and whatnot, right? So that we can get better videos and whatnot. Any feedback would be appreciated. Like I said, I've also been planning on a project courses as well, focused around web development mainly because merge stack is something I'll do a lot on a daily basis. And that's pretty much it, I would say. Take care, everyone. Thank you, and have a nice day. Bye bye.